Friends, at the outside, let me feel very comfortable and very happy to say this good morning to all of you because I started my career somewhere in the west in Rajasthan with a Precambrian geology and an investigation on fluoride deposits of Rajasthan and Gujarat, especially the epigenetic linkages, the type of mineralization, because fluoride was an industrial mineral. It was a flux grade fluoride and required by steel industry. So there was an investigation in that direction. So I was asked to search for that. Prior to that, I worked in Andhra University as a research scholar, and at that time, the type of investigation that was done by me at that time was on mineral deposits alone. Mineral deposits means anything is a mineral. Your quartz is a mineral, your chalcedony is a mineral, your zircon is a mineral. But minerals which are useful to you and me and industry are industrial minerals or economic minerals. And the geology tagged up with that is economic geology. So economic is only a connotation to describe the utility of a mineral vis-a-vis the demand and supply. So anything is a mineral. So I worked on the so-called economic minerals because there is nothing like economic as far as a mineral is concerned. Mineral is a constituent and an integral constituent of a rock. Every rock is composed of minerals. And rocks, as you all know, igneous, sedimentary, metamorphic, so they are all there. So minerals are useful to us, we all know about. Even the prehistoric man used a flint or something for his hunting. It is a mineral. So he depended upon minerals. Subsequently, iron was understood. Iron was used as for an industry. So we all progressed, human civilization progressed with the utility of a mineral. There was something like a copper age, a bronze age. All these are related to utilization of what we call metals. So we are that way, we are living on this habitable planet, and this planet is giving us all the resources. And with time, humanity started somewhere, maybe let us not bother about the geological econs, maybe quaternary, echelons, this, that, millions of years, evolution from ape or this, that, all that let us forget about it. But there was a civilization, maybe at a mark 10,000 years ago. There was, or 5,000 years ago. And progressively there is utilization of what we call metals. Metals which were known, metals which were understood, and minerals which were utilized by humanity. So this way, it is a symbiosis with the progress of civilization. And Earth is a planet endowed with minerals, endowed with its own geosphere, a lithosphere, a biosphere, and a hydrosphere, all these working in tandem in an atmosphere. So that is a complete geological, geophysical, geochemical process going on, leading to what is called the formation of mineral deposits. Mineral is what we need, but it is formed by a particular process. So minerals are there, and these are constituents of elements. Elements are there, so there are minerals. From the beginning we knew iron as an element, and iron, if we understand, was the element in which the earth is dominant totally. If we take earth as a planet and assign the abundance of an element for the planet as a whole, iron stands as number one. Earth is an iron-rich planet. If it is iron-rich, I don't want to segregate all those points. There was an iron-rich nickel core, there was a stratification, there was a core mantle interaction, there is an upper crust and a lower crust, and iron was there as an integral constituent in all your mantle rocks and your crust rocks. Iron is the most abundant mineral as far as Earth is concerned, but iron is not that abundant in other planets as well. It could be. Earth is a magnet. Earth is having a magnetic field. So this way, if we know about all the elements, there are about, as things stand today, the periodic table with its 7 rows or 18 columns was completed. that formatted periodic table. Maybe another periodic table might come, that we don't know. Your generation might be seeing. That was completed with 118 in number. The last element with atomic number 118 is there. It is an artificial element. So let us forget about artificial. How many are there naturally occurring? 92 are naturally occurring elements. The 92nd one is your uranium, heaviest, the so-called heaviest. There are other heavies, all artificial, but not known to nature. So in these 92, one is not abundant on the earth. That is again element. Why I am combining both the elements and minerals? Because nowadays the present day civilization needs both the minerals as well as the elements, and the elements which is extracted from those minerals which are the housed in them. All this is the process. So let me take both these things in an interchangeable manner. So elements constitute the mineral. Minerals are constituted of elements. All these are known to you scientifically. But today, in a way there is an exchange. So in these 92 again, one is not known. Technetium was not known on the earth. There is an element in that table below, manganese or something. But it was artificially made. Artificial making of the element and nuclear techniques, all that is a separate thing. It was known, but it was not available on the earth. So there are 91 elements. In this 91, we are using. If we really say we are using almost all the elements in this 90. Some way or other, civilization, present day high-tech or low-tech or whatever it is, tomorrow it may be a day when we are going for carbon neutrality. Because industrial pollution or whatever be the reason, climate change, if it is an imminent landmark tomorrow, marking the universe, earth as a whole, there should be a remedy. There should be a way out. For that again we need again the minerals. We need again some of these elements. Then again I will just touch upon some of those points. So we are dependent upon them. In these 92, one is not there. The other all are the elements. The first element is hydrogen. Do we need them? Do we need it? We need it. Tomorrow it is a hydrogen economy. But it is all hydrogen. Hydrogen is known. The first element, the element of element. Single proton, no electron around. With electrons it will be an isotope. Hydrogen 1, hydrogen 2. And why we are bothering about H3? H4 is another thing. If we add it up, it will become helium. It is an electron structure. H3 is another important constituent, may be available on the lunar surface. Tomorrow there may be an excavation of H3 isotope from the lunar surfaces. There can be a competition. So it is a resource. It is a wonderful energy source provided we get it. Is the H3 available on the earth? No. H2 is known. So this is from H onwards up to U92 we are using them. So are they occurring? Are they occurring uniformly on the earth? Certainly it is not. Geographically the minerals are unevenly distributed. Geologically unevenly distributed from Precambrian to Quaternary, and uneven distribution of minerals. When once it is there is a dominance of particular element in one area or one geological horizon or absence in some other area. India is having a particular scenario where, as we know, understand today, uranium is not that much geologically favorable in our country. It is known. Rampalli is a Kadapa horizon having uranium. But is it enough for our country's needs? We require uranium-235 immediately for our nuclear reactor. Have we got abundant resource of uranium-235? Uranium-238 might be available, but that too, uranium is not that much in our country. Thorium, we are having enough. Our monazite resources are there. There is abundant thorite along these placer resources and all that. We are having thorium. So uranium and thorium, etc., will form your nuclear front, your atomic minerals. But we have to depend upon other countries for uranium. So if we need uranium for that, we need to depend upon again our geology. Where to locate? Are we having favorable locales? Why some country like Colorado or Canada or Alaska is having more of uranium? Why India is not? Answers are not well known because geologically certain factors would be favorable for a formation of a mineral deposit. Maybe lithology, maybe stratigraphy, maybe structural, maybe geochemical, maybe combined, maybe a geological time. All these factors again lead to the formation or disappearance of a mineral deposit, and we have to search. Now coming back to what are critical minerals. My topic today will be slightly to focus on. Tomorrow we need some critical mineral. This critical mineral is also a very favorably located general terminology. Don't think that criticality is added to something like a technical fixation. It is not. Critical minerals are those needed for a country's economy, industrial otherwise, or some other purpose. So, high-end industries need some mineral, critical mineral, or we have it. Because tomorrow's civilization is dependent upon not only high-tech industries, but also upon your so-called projected problems of your climate change. This also should be addressed synonymously with what you are doing for excavation or exploitation of minerals. Because if that is imminent, what should we do? We should go for a some other economy where that type of carbon emissions have to be eliminated. We have to use some other energy, maybe solar energy. What does it require? It requires some other components. For that again, some other elements. So how to search for? So it is all a closed circuit. So this way, we are related to a particular problem where critical minerals are in need of the country, and the critical minerals, some of them are not available in the country, and organizations like GSI may be called upon to do a further search or locate further mineral deposits. It might become a problem. So tomorrow, maybe you are working on land. Tomorrow if I go to Visakhapatnam, they say they are working on oceans. So as far as Earth is concerned, this Earth domain or land continental domain or oceanic domain, they don't remain different. This is a single domain. About 78% is oceanic terrain and 22% is the land mass. And our continents are there. We are already excavating all that which is available in the lands. Already some of the elements are totally exhausted because all the elements are housed in the upper part of the crust. Even if something is there in the mantle, upper mantle or some other thing, can we really excavate it? We cannot. The deepest mine somewhere in the Kola Peninsula in Russia must have gone to I think 5 or 6 or 6.5 kilometers. So there is a limit. Minerals are housed in the crust is known. Crust is a favorable locale. Yes, we know it. But what is that crust? Is it a simple oceanic upper crust, 10 kilometers in thickness? Or is it the lithospheric crust, about 100 kilometers in thickness? Where do we go about? There are lots of techno-economic considerations. Supposing you say there is a deposit. Deposit means economically viable. I am using the word deposit in a general sense. Is it economically viable to be extracted? Critical mineral deposit. Deposit means I am defining it. Actually, there is a rigorous classification about classification of mineral deposits. Defined category, assigned category, determined category, foreseeable category, future category. All these are there. But government does not believe in all these things. Tomorrow you are asked to show something like molybdenum. Mariappan is telling we are searching for molybdenum. Tin, tungsten, molybdenum. All these are essential things for a high-tech industry. But all these will not occur together. They are platinoid group elements. 6 in number, somewhere like platinum, osmium, radium, rhodium, etc. They occur together. But can we locate them? If we have to locate them, what is the scientific basis? There is no signboard where it is written, here it is a platinum deposit on the surface of the earth. Here it is a copper lead zinc deposit. There is no signboard. Geology does not have. So your signboards you have to create. That is on the basis of your geological exploration or geochemical database or geophysical signals, you have to create. You have to say that this is a favorable area. So for that, you know the environment, you know the geology, you have to frame out where to occur, where to locate. So all this is an interlinked game. That means one has to go with the available data We have lots of data. Geology data bank is there. Hundreds of geological maps are there. One structural map, one another map. All these maps together. Maybe if we put them on the same scale, along with the geophysical maps, along with the geochemical anomaly maps, if we put them in an overlay, use your intelligence or artificial intelligence or whatsoever, can we get something meaningful to interpret it? Don't think that your AI is a technique which if you slot in your thumb you will get a signal. You cannot. Geology is that complex. Geology means Mother Earth. It is not that easy. It is not such a sophisticated thing is to be easily unraveled this way or that way. So use all the techniques, use all the available data and come to a breakthrough. This is what is called a conceptual prognosis. So in this way if we go about, tomorrow if you are called upon to search for critical mineral deposits, what are these critical mineral deposits? How to go about is the task before GSI. There is an energy, there is a twofold thing. One is your energy business. Somebody may be asked, how to come out or combat this climate change? Can we do something? Because it is not in the single hand of a single individual sitting in the ministry. Combating climate change is not exclusively in the hands of X, Y or Z who will sort in his program and do it. It cannot be done. Can we do it? It requires global cooperation. Good, we agree. It requires a Paris Agreement. Some country has signed, some country has come out. Can we do that way? Can the carbon dioxide emissions be eliminated? Everybody should do a little bit. If not, what to do? If to eliminate carbon dioxide emission, we should avoid the petroleum products. Petroleum naturally is one thing. It is available in the air. Tomorrow or day after, at a particular finite point of time, it might come to an exhaustion. The zero reserves will come. Then what to do? We have to depend upon renewable energies. So energy and mineral are the two fronts where GSI or any other Earth organization can contribute. These two are inevitable for human civilization. So both are going together. So in this way, if we think about, these are all related things. Dependence on critical elements or critical minerals is a must for any advanced civilization. But in what way and in what fascination we have to do it is all to be thought of and to be done with a collective endeavor. We will not think about the policies between this country or that country or that country. Geopolitical considerations are heavy. As I was telling, certain countries are endowed with rich resources of minerals. But will they give it to us free? They will not give you. There is what is called stockpiling. China is rich in rare earths. Will they give you rare earths? If we ask them, supposing a ministry letter goes, will they give you? Neodymium is required for supermagnets. Neodymium is a rare earth element. Will they give us a rare earth mineral? Will not. If that is so, we have to search for ourselves. So certain elements, to a large extent, we have to depend upon ourselves. Self-sustenance, self-survival or whatever it is. To some extent, there can be a liberalized program of mutual exchanges between countries. There are agreements, bilateral, this, that. There are other aspects with which the governments have to be concerned. But the governments will entirely focus on the resources within the country. The resources within the country are limited to either the land or the ocean bed. How far we have done the ocean bed. My ocean friends can tell me. I have a lot of experience. Till now, I can tell you, I worked in marine for more than 20 years. Till now, except some coastal territorial water placer accumulations which were mined by some countries, till now, there is no sensu stricto ocean mining. There are authorities like International Seabed Authority, UNCLOS program, so many things are there. But can we recover the deep sea nodules which are lying at 4,000 meters depth? To whom it belongs? Can we recover the gas hydrates? We will talk about sweet things. I will tell what are the ocean resources. But what we require, I will just touch upon it. So ocean bed is still unexplored. And again I am telling,
but ocean bed will be your next launching pad. But to that extent, we have to depend upon land, but quite a large extent, and research and re-look into our own environment for what we think as the critical mineral or the critical element. So, coming to about what are these things, so-called critical things. Critical, again, I am not telling you with a definition, because in elements there is a classification, major, minor, trace. That depends upon the abundance level. Critical means it is a statistical relative term where it is required if somebody is in critical care. That means this fellow is requiring a lot of attention. Critical mineral means something which is essential for your hinge and backbone, for your industry or some other thing. That is the criticality. So like that, if we see, many elements come under this. So to name them, rare earths are one. So how to locate the rare earths? Is it one program? Is there any program? Are there any rare earth minerals directly which are mined? Except China. I think also in different geological settings, no country, there are other countries, I am not able to locate them right now, they are not vigorously mining. China is mining. But rare earth minerals, where are they? Rare earths means, all of you know, there is a group in the periodic table at the bottom, nicely styled. Lanthanum will be shown in the periodic table. From cerium onwards they will be shown. From 58 atomic number up to 71. From cerium to lutetium, there are 14 elements. But all these 14, will they occur? How to locate? What are the geological controls to see those minerals? Are there any primary minerals? First thing is the critical elements is rare earths. Why rare earths? Let us see a little bit later. How to locate them? Rare earths, as we see the position of lanthanum, it is next to calcium in the periodic table. It follows calcium. Calcium is an alkalic element. So calcium minerals and rare earths supposedly are supposed to be together. And if we really go that way in a scientific postulate, in an apatite, which is a fluorapatite, fluor means it is only hydro, it is a calcium phosphate, it is an apatite. In that structure, the position of calcium is occupied by substitution by rare earths. That means rare earths don't occur as a major mineral. They follow calcium. So if we analyze an apatite, because why I am emphatically telling about apatite business is I worked on apatite for 3 years. There was an interesting apatite mineralization in Andhra Pradesh, probably the only mineralization where giant apatite crystals associated with a magnetite are seen. That means apatite, magnetite, vermiculite. It is a mineralization in Precambrian. It is a vein type mineralization. It is zoned pegmatite. So in that apatite, personally I analyzed them. Personally means I didn't take the burette and pipette. I will not. I don't know qualified chemistry. I sent these samples to somewhere in US Geological Survey in America. This was long ago. So why I am telling these small points is, science is built around minute and important critical loci. And surprisingly, that apatite was rare, rich. Only that point I wrote in the thesis. This apatite which I analyzed is not only rich in fluorine, but also rich in rare earths as far as cations are concerned. Cations are metals. So calcium is substituted by apatite, rare earths. So rare earths are housed in some other primary mineral. So this is one clue. So let us search. So simply there is now a magic wand where we can go with the magic wand and that magic wand turns blue and red. It is impossible. So this is a clue. So rare earths are a dominant need of tomorrow. Why it is? Let us see. Rare earths, lithium, as you all know, lithium batteries and all that, cobalt, copper, nickel, platinum group elements. These are all well known. We know about them. But tomorrow again they are re-needed for some other special purposes. Those things just let us try to peep about, because not only high-tech industries but also your global climate change, what you need as an equipment. All these require some group of elements which are needed. So tomorrow you have a role to play. So rare earths, lithium, copper, nickel, cobalt, tellurium, gallium, even titanium and graphite. These are all required for tomorrow's growing technologies. So where to look about? That is the important question before all of us for that matter, because I belong to GSI like So energy, clean energy. Again it requires some of these components. Why it is required? Because for climate change you require your wind turbines, your solar panels, electricity generators are there, electric vehicle networks are there. All these require these elements alone. So for climate change is one route and high-tech industry is the other route. The superconductor, your TV circuit, for that matter little things which I know. That gadolinium is required for your supermagnets. So you have to tune your thinking. I will just list about some of the uses which elements I have told you. Lithium is in power resources, batteries for electric vehicles, cobalt is in batteries, antimony for the flame retardant, nickel, batteries, copper, electricity transfer and storage, tellurium, photovoltaic and solar cells, and it is very critical to know where tellurium occurs. I'll just come about, because if I have a time, I would have given each element one small note out, how it to be tracked out. Because this type of things, while I was in US, I was just going to some places, libraries, some universities and all that, and trying to collect with them. I am not a regular employee or anywhere, but a number of trips I went abroad. So wherever I went and whenever I went, I used to utilize those things to collect some data. I was sitting very close to very famous laboratories in New York. So they were giving me lots of, where anything is free for them. If you go to any library, they will give anything free. You can ask anything, sit day and night and read it. And if you want a book to be given to you, you just ask your friend, they will give 10 or 15 books on a loan. So all these facilities are there. So those things, so tellurium is used, gallium is in IC circuits, LEDs, solar photovoltaics, semiconductors, and as I was telling, the importance of REE for renewable energy technologies, high performance magnets, these are used in electrovolt motors, wind turbines and defense applications. Then PGEs for catalytic converters, fuel cells, cancer drugs, and then jewelries to some extent. Niobium, high temperature superalloys, next generation capacitors, superconducting resonators. All these are today's needs. They were not there 50 years ago. So go with high technology, go with a climate change. Both need a common denominator, that is some amount of abundance of elements or minerals for which the country is to be based. And no other country will give you. If any country approaches China today, I don't know whether we will be able to get it or not. Rare earths are a commodity of tomorrow, of today. So we have to search for rare earths. So how to go about is, these occur in different environments. These minerals occur, as you all know by now, there is no stratified rule that this element occurs in this environment and this is the loss of product. It is not. Supposing you are having an alternative suite of rocks, your igneous layered complexes or something, there is what is called a cumulative differentiation. You will have chromium. You are having along with chromium, titanium, vanadium, and along with titanium, vanadium, even your PGEs. PGE gets accumulated in sulfide inclusions in all the ultramafic cumulates. I went to Sudbury, Ontario in Canada and saw the Sudbury complex where they are having platinum mineralization as a sulfide. Are we searching for all our ultramafics for platinum? Is there any data available? Well, to relook. I don't say no, yes, yes. I don't know about that. But there is nothing wrong if we have a relook at our own studies, what data we are having, on our ultramafic rock. There are various ultramafic rocks in the body belonging to different tectonomagmatic levels. Maybe Precambrian, maybe upper Precambrian, maybe Proterozoic, maybe a tertiary. There are platonic complexes. There are ultramafic rocks. And some of them are called ophiolites. I don't want to explain again what are those ophiolites. They are all intrusions, tectonically lifted masses. They are all having special alpine type of peridotite are there. Alpine chromites are there. What type of elemental assemblages are there in those shoes? So we look for PGE in this type of environment. So PGE is a defined project. So where to look for? Mafic rocks are suitable, ultramafic rocks are suitable, peridotite are there, and then there are pegmatites. In all the pegmatites we can look out for our cesium, tantalum, niobium, all those minerals. And carbonatites, we are having widely some carbonatites in India. Carbonatites is having a niobium. There is no other environment favorable for enrichment of niobium except carbonatites, alkaline rocks. So a type of relook into what we are having, we should again proceed. So ultramafic rocks we have to see, then volcanic massive sulfides, VMS type of sulfide source we have to re-examine, and then different type of pegmatites. What I was telling this hepatite accumulation, it is a pegmatite. It is a pegmatite in a Precambrian, but that pegmatite, that hepatite is extraordinarily rich in rare earths. So rare earths we have to conversely we have to see only certain. But all the hepatites may not hold, because an hepatite may belong to a granitic soup. A simple granite, calc-alkaline granite, does not have enrichment of rare earths. Rare earths follow only that more calcic, more alkalic type of enrichment and soups. That means more carbonatitic affinity. So if we search all the pegmatites, and if we look at some of these pegmatites as calcic, as more calcic or alkalic, or different shades of some carbonatitic rocks, then there is a possibility of rare earth elements. And for that again, you have to see the pathfinder. Pathfinder is a barium. If there is an accumulation of barium, because as I understand, GSI has already completed its geochemical mapping, maybe soil samples or something. So examine your data. You are having a lot of data. See the anomalies. Wherever there is a thought-provoking anomaly with you, couple it with your geophysical friends, geophysical anomalies. Couple it with the geological maps. Your systematic geological maps are available. So let us relook our data in terms of defined new concepts. It is not somebody will not come from outside and tell you. Once upon a time something like BRGM was coming to India and advising all of us. But nowadays I don't know whether government will allow all such things or not. We have to do ourselves. So let us churn out some data. So all the environments are travelable for the elements that I will listed. Your igneous, your sedimentary. And for that matter, I just tell you one thing. You have iron. Iron is an example. You have titanium. Iron is occurring in a primary environment as a magnetite. We all know about it. Apatite magnetite is there in Kiruna in Sweden. It is a particular type of association. Kiruna association. Apatite upside ore or something. So that there. So apatite and magnetite are there. That magnetite is not that susceptible for working out iron as hematite is. Hematite is more useful for removal of iron. And hematite is more abundant only in sedimentary rocks. So sedimentary rocks are holding 85% of the mineral resources of iron than your igneous rocks. So sedimentary rocks cannot be overlooked. For all these elemental enrichment, sedimentary rocks are next possible or the best possible environment. They cannot be avoided. Your phosphorites. How many of phosphorites in India are re-examined? Phosphorites can contain uranium. Phosphorites can contain rare earths. Phosphorites can contain other elements which are assorted which are related to carbon fixation. There is a sandstone type of uranium vanadium accumulation that is purely sedimentary and metamorphic. How uranium occurs in a sandstone type of an environment and vanadium occurs there. Vanadium closely follows iron. But there is a particular type of fish in a bioenvironment. The fish is called tunicates. If you analyze that fish, I am not telling you analyze it chemically, that fish is extraordinarily enriched in vanadium. Why? I am not telling that this is a story, but these are all things which have to be tagged up. That means vanadium gets into a secondary geological, geochemical cycle much more readily than primary cycle. That is why it is more useful there. It is going to be a sedimentary environment, uranium, vanadium deposits. Same thing is with uranium. Uranium occurs in primary environment, but very much less, only 5%. 85% of uranium occurs only in sedimentary. How we search? So sedimentary rocks, as I am telling, is again another hold. Your placer deposits, your monazite you all know, it is cerium, LA, phosphate and all that. In addition to cerium, this monazite, there is the yttrium phosphate, again rich in rares. Your placers hold a potential. Banded iron formation, wherever they are holding a potential for all these elements, especially cobalt, nickel, rare earths. The third one is phosphorites. There are phosphorites in India. Even in marine, there is phosphate accumulation in the recent. It is all recent. But even there, have we totally examined our recent sediment content or present day sediment in terms of uranium and rare earth? Have we analyzed them? There are deep sea muds. Have we analyzed them? So deep sea environment, as I was telling, it is totally difficult one right for mining, even if it is available. There are black smoker deposits, sulfide deposits, everything is there in the ocean. Lithium is available in the ocean, and they require it. But lithium is available in the brines, many brines. Brines is saline solution. Why not we re-excavate our lithium content of different brines? Lithium is such an essential element. Lithium is a very, very crucial, cosmochemically also, it is a cosmic element. It is available in the stars. And if we see the periodic table, lithium is the first metal. Hydrogen, helium, lithium. So all these, then black shales. Have we analyzed our black shales? So we have to re-examine our maps. Then supergene enrichment. Just now I was telling Mariappan, I wrote a book otherwise very recently on bauxites of India, East Coast bauxites and the West Coast. So comparative geology, geochemistry, not the deposit wise, not resources, but they feature how much gallium is there in the East Coast bauxite, how much gallium is there in the West Coast bauxite. Such things I have written. I'll send all those PDFs. But what I was noting at that time was not the time, but today is the time, the need of the hour for the country. You have to do something. You are the future. So, nothing should be left out. Ocean environment I don't touch now, but your sedimentary, you examine your maps, you have banded iron formation, somewhere, you have your phosphorite, you have your black shales. Black shales are organic rich deposits. In that organic rich deposit, carbon plays an important role because uranium is an element having many oxidation states. So it gets fixed up only in sedimentary cycles by dissolution and precipitation, not in the primary cycle. Same is the case with vanadium. So we have to go about thinking in a different way. Our chemistry people are there. They will help us quite a lot if we ask them. Because I was sitting with our chemistry people while we were doing some marine analysis long ago. With their plain photometer, I was sitting there. He was telling me out of curiosity that this is a lab. So color showing for lithium. He was telling me at that time, my chemistry friend, that lithium is there in the marine samples. He was telling me. And what have you done fully? So forgetting about the ocean business, to concentrate on land work today, all these sedimentary environment, banded iron formation, phosphorite, black shale, laterites, bauxite, keep a specific objective, at least 1 year. Don't think it is a 5-year project or this, that thing. You can't be drawn up. As a pilot project, examine it, because those elements which I have listed in the beginning are those which are needed by the country today, tomorrow, and day after. You may recall that. So, certain categories, I don't want to now compare land deposits and oceans, because ocean is a big business. There is another very complicated business. And as I have stated, some countries have done experiments for mining, but no country has started. It is not that easy also. But less expensive and more available deposits are there available on the land. Let us re-examine them and let us look out for these elements in a better, conceptually driven prognosis and help build the nation towards the needed resource. With these few words, I like to close my things, because I am a freelance man. Now I am having no job. Just I came here to share some of my wild thoughts. It is not a textbook. Literally, for speaking, I don't have a single publication except for the progress reports I submit. I am an unpublished material except for GSI. But still, I am having some wild thoughts. I sit with my friends always and talk to them. So let us resolve a problem in a better, sophisticated, science-driven way and towards definite goals. Supposing you have a bauxite, supposing there are some anarchites, re-examine them again whether there are a PG accumulation. PG will not be there all unless there is a correlation between some mafic minerals or something. Try to examine. Don't go wild, but go with a better sense, and then definitely there are tools. Thank you all. I thank Narasayya sir for having given me encouragement, and my friend Nagendran, who is both ocean and also land. Let them think about, because you stand before the nation with tomorrow's challenges, and you have to make a solution. Thank you.
Anybody want to interact with him?
Any question? By the box between two. Any questions? If I can answer, I shall answer. It is a pleasure for me. My daughter has given me an opportunity to come to Chennai. Otherwise, I